Hello, everybody, and welcome to today's webinar on aluminum blocks. My name is Amanda Goyette. I'm an admin assistant with AERA, and I will be in the background today helping moderate today's event with my colleague, Rob Monroe.
Hey, everyone. Yeah, Rob Monroe here. I look after membership and technical development at AERA, and I want to welcome you to today's webinar with Dave from LA Sleeve. We got a real treat for you. Dave's a wealth of knowledge when it comes to sleeving blocks, aluminum, cast iron, power sport, anything that you have. So really looking forward to this webinar. We get lots of questions on the tech line about sleeving, and Dave is definitely our go-to guy for answering some of these questions. So the other thing that should have happened, you definitely should have gotten your Q2 Engine Professional magazine already. That hit mailboxes probably about 6 weeks ago, and we're just wrapping up Q3. So looking forward to getting that one out. This magazine loaded with all kinds of application-driven articles, stuff that you can use right away in your shop. If you can't wait for a subscription or you don't want to do it that way and wait for your printed copy, you can go right out to www.engineprofessional.com. And of course, you can read the magazine on our digital format and read it there. So I want to bring on Dave from LA Sleeve. And like I mentioned, he is our go-to guy for anything that we have. And when we do get quite a few questions on the tech line about sleeving, especially some of these newer blocks and some of the power sport stuff. So Dave, how's it going today?
Today's going great. Thank you so much, Rob. For those watching out there, I want to thank you for the opportunity for me to give my introduce our company. If you've never heard of us, if you have heard of us, welcome back. Thank you for being a part of this. Just a brief history on LA Sleeve, if you don't know about us. LA Sleeve being Los Angeles Sleeve Company. We started in 1945 in Los Angeles, obviously. This is a family business. Grandfather started the business in 1945. We've been manufacturing here for 80 years. We've moved from Los Angeles to Santa Fe Springs, California, which is a suburb of Los Angeles. We're still doing it today. We've been in this particular location in Santa Fe Springs for almost 50 years. That's allowed us to continue to manufacture at a competitive rate. As some of you may or may not know, the business environment in this state could be a little tough for some, especially manufacturing, but we've been able to sustain all these years. The materials that we use are made in the United States. We have 4 vendors that provide our material. The thing that some of you may or may not have noticed in our marketing for all these years is we weather treat our material. Weather treating is a process which is exactly as it sounds. When our castings are centrifugally spun cast, they go through a heat treating process. They anneal to provide a particular hardness for the material. And when the castings are produced, we actually let them sit in the yard for as long as 3 to 4 weeks before we actually machine on the material. Cast iron, whether you know this or not, there are living molecules in cast iron, and it does take time to cure. Although these days the heat treating processes are so much better than they were 80 years ago, and our foundries, although they promote a perfect product when it comes off the line, we still do like to have that old world technology. Weather treating was started in Germany. It was discovered that the material will harden laying under the sun for a certain amount of time, and to this day it proves to be true. The machines that we use to produce our sleeves primarily are CNC these days. We do have some manual machines, manual lathes that we still tweak some sleeves or produce some custom sleeves. But for the most part, we are fully CNC operated. Machines produce a semi-finished product. The outer diameters are then put into a centerless grinder. The grinder will then finish the outside of the sleeve, providing a real high quality roundness and straightness to the sleeve that allows the installer the ease of taking the sleeve, measuring one, and knowing that the other 4, 6, or 8 sleeves that are going in that block are going to be the same size. And so we're fighting the good fight. We feel comfortable in our position in the marketplace. If you've studied anything about our company, you probably see keystrokes that are somewhat prominent on our website and in our marketing. The reason for the keystrokes in our, there you go, to give you an idea of our sleeves. The reason we're so fond and grateful to the two-stroke market is going back to the late 60s. The marketplace had changed for our company, and at that time there were quite a few products coming in from out of the country, Japan primarily, as we were rebuilding their country after World War II. And so competition was stiff in this country, and at that time we had the opportunity to produce two-stroke sleeves from Mercury Marine. And through 1968 through about 1978, the two-strokes sustained our business. And from that point on, it built us to a position in the marketplace where we could have the ability, the latitude to go left or right regarding where the market was going, be it automotive, industrial, two-strokes, compressors. And since that time, we've had the ability to market ourselves, present ourselves to the OEMs, be it General Motors, Ford, Chrysler. We're OEM for Mercury Marine. I mentioned compressors. We're OEM for Carrier Corporation for many years. And the compressors, again, another particular marketplace that's dear to our heart, as it helped us sustain through the 70s, which was a difficult time for manufacturing in this particular marketplace. And so through the years, it's given us the ability to learn how different engines require different types of sleeves. We're well versed. We produce sleeves as small as 1 inch. We make locomotive sleeves and brake caliper sleeves as large as 8.5 inch. And so that wide range of sleeves, be it two-stroke or four-stroke, has given us such a great position and great experience that we could take a phone call from anywhere in the world for any particular engine block and have the ability to offer advice or produce a sleeve that can get the job done. And so through these years, we've learned where we need to be. And so today's particular focus is on aluminum blocks. And the aluminum blocks are so prominent in our marketplace in the engine building that I wanted to focus on aluminum blocks, but not exclusively. So before I get into that, a couple of things I wanted to touch on that I think are most important to the installer. For those of you who have used sleeves from different vendors, I would think that you've learned there are different qualities that are out there. The sleeve materials that we produce are gray iron, gray cast iron, ductile iron, steel, aluminum, and we've actually produced some titanium sleeves as well. The idea behind sleeving blocks is using the proper material for any given application. I wanted to give you an audible lesson on materials. Those of you who have used different materials in sleeving have noticed there are softer materials and harder materials. Here's a basic cast iron sleeve. The sleeves that we produce, for the most part, cast iron, will go into virtually all applications in the marketplace. We also produce a material, ductile iron, which is cast iron, but it's a harder grade. This is one test that I'd like you guys to keep in mind from this point moving forward. If you wonder if you have a good quality sleeve, you can do an ear test. This is something I like you guys to focus on moving forward. Listen to this. This is gray cast iron. Makes a decent sound, but there's sort of a dullness to that. Now listen to this. This is ductile iron. You could tell by that high pitch, there's an audible difference to the materials. The reason I'm bringing this up is I had a customer just this week call me, purchase some Duramax, 6.6 liter Duramax sleeves. As you guys know, the diesel blocks, the light duty diesel blocks are hardened on the deck. And this customer, who was very wise, decided to test the hardness on our sleeves and found that the sleeve hardness on our sleeve didn't match up to the block. And I'd asked him how he tested. He did a surface test, Rockwell test. And so this particular customer had various brands of sleeves in his shop. Good engine builder will have sleeves from every different vendor just so they have the options to go with particular brands. And so I'd asked him how he tested that sleeve. He told me, surface tester, which came in way softer than our particular ductile iron sleeve, which we make for the Duramax. The reason we make the ductile iron sleeve for the Duramax is we try to mimic the block as far as the surface hardness on the deck of that block. So our sleeves, being centrifugally spun cast, are hardened from the deck of the sleeve, which is a flange top sleeve, to the bottom of the sleeve, unlike the blocks, which soften as they go down through. So I asked my customer, I asked him if he could get a piece of steel or something rigid like this particular metal ruler, and I asked him if he could take a sleeve that he had in the shop like this and tap it, which he did, to reassure him that our material, our premium material, was better than what he had suspected based on his hardness test. He had taken our sleeve and he eased his mind that he was getting a premium sleeve for a block that required a premium sleeve. And so these are the different materials that are, in our estimation, required for any particular application. The aluminum blocks, although gray cast iron sleeves are adequate for most applications, engines that are being boosted, on the other hand, that's not the case. I like to give you another real world example. Many of you, or some of you I should say, may have noticed this on the evening news this week. Southwest Airlines, they had an issue in Phoenix, in New Mexico, and in Las Vegas. The issue was, because of the extreme heat that they're experiencing right now, their soda cans, like this Coke can right here, were exploding from heat. Why I thought this was an interesting example is, although many of you probably already know this now, this soda can, which looks no different than a sleeve, obviously, it's round, it's straight. These are intended to hold a liquid or a compression under certain conditions. Well, Southwest, they were having their soda cans, or their Coke cans, if you will, explode because of the extreme heat. The can, which was designed to hold carbonated beverage, obviously, could only withstand so much pressure until the point of where it exploded, and they did. The cans were exploding right in the hands of the flight attendants. So the real world experience that I think is relevant for the newbie, if you will. Aluminum blocks, they're made for certain cylinder pressures. Aluminum blocks are made for gasolines, some E85 ethanol, and race fuel. They're also spraying with nitrous. They're supercharging the engines. Well, a gasoline engine, a regular sleeve like this, it's going to hold up just fine. When they put those extreme boost pressures into those blocks, that sleeve, like these soda cans, they're going to explode and they're going to crack, and they do. Thus, that's where we come in. We provide a material for the average engine block that's going to be pushed beyond its levels. And so, that being said, we've attending the AERA conferences or attending PRI show, SEMA show, different trade shows out there. It's interesting talking with engine builders and machine shops. We get a little flippant. I'd say I'm going to use the word flippant in this respect. We think that the OEMs, when they build an engine block, especially an aluminum block, which we're focusing on today, that they don't know what they're doing. Boy, that couldn't be further from the truth. We've had the opportunity to provide sleeves, custom sleeves for Ford, General Motors, and Chrysler over the years, as well as some other OEMs. And I've been given the opportunity to walk through Ford research and development, for instance. And I've looked at their aluminum block program going back to 2002. They're producing the V6 blocks, which you see in the Ford pickups, their V6 turbo block. Those blocks were developed 15 years prior to the release of them in these cars. They've done so much research and development. These hydrogen cars that you've seen a few of those hydrogen motors that Ford produced, that's technology that's amazing that we see out there today, but it's 20 years in the making. And so an OEM who produces a block, be it a V6 or a V8, they're made and intended to do exactly what they were designed for. Ride on the street, produce a certain amount of horsepower, and provide reliability. But when a block breaks, when we produce horsepower that they weren't intended for, you get a little flippant. We think they don't know what they're doing. Oh my goodness, they do. But we need to be ahead of the game. And so when we see certain boost pressures crack sleeves, we know we need to get in, provide a product that's going to reinforce the blocks. So before I get into that, one more thing I want to focus on as far as the installation of the sleeves. So the aluminum blocks, as well as cast iron blocks, be it using a ductile iron sleeve or a gray iron sleeve, regardless of what material is going into the block, they have to be put in properly. And installers who've been around for years, they're familiar with this term. And the term is called sleeve drop. It's when a sleeve drops below the deck. I'm going to show you an example of an LS7 block that we see every now and again. My assistant, my right-hand man, Daniel, is going to show me, bring this block into the picture. This is an LS7. This is a cutout of an LS7. This particular block uses a flange sleeve, as you can see here. These sleeves, obviously you can see the flange. When they go in, if they're not bottomed out properly into the counterbore, as you can see here, they can drop. Thank you, Daniel. And so sleeving kind of gets a bad name. Those that have been around the block a long time know that this can happen occasionally, but if the sleeve's put in properly, we're not going to see an issue. The reason I wanted to bring this up before I got in further into the aluminum blocks is for any good machine shop, or any good installer, their biggest fear will be sleeve drop. Fear won't be if the material's right, if the sleeve is going to survive under heavy pressures, like I indicated earlier. It's going to be, will that sleeve be in place for as long as that block is intended to run? Forgive my crude drawing right here, but this is something I think is very relevant. What I'm going to show you here is a sleeve and how it would sit down into a block. As you see here, the sleeve has an outer diameter chamfer right there. Let's see if I'm getting a good shot here. Yes, here we go. Hope you can see that. Inner diameter chamfer and an outer diameter chamfer. Oftentimes, when a sleeve is installed, if it's a straight wall sleeve, the sleeve will have outer and inner diameter chamfer on one end and a straight cut 45-degree angle on the opposite end. When the sleeves go into a block, if the landing area or the register for that sleeve isn't adequate, what can happen is the sleeve will push itself down past this register area, as you can see here. I think this is so important to focus on for the installer. If you've done it before, you know exactly what I'm talking about. If you're getting into it, if you're beginning to install sleeves, please focus on these two things: the quality of the material, the environment of the block that it's going into, and how it's being installed. The sleeve, if the register isn't properly machined, when that sleeve goes in that block, what our main focus, or what our main concern is, I should say, is will that sleeve stay in place moving down the road? And so for an LS7, as I've indicated earlier, or just a 350 small block Chevy, when that sleeve goes into the block, know that if the seating area of that sleeve isn't flush, and if the sleeve doesn't go down flush, as I've indicated here, that sleeve can drop in the future. I mentioned the light duty engine blocks earlier. Focus on Ford, 6-liter Ford, 6.4-liter Ford Power Stroke, or 6.7. If you've ever sleeved a 6.4-liter Ford, you'll notice at the bottom of the stroke that the iron of the block is free floating. And when putting in a straight wall sleeve into that application, what happens is, because of the flimsy nature of that free floating area, when the sleeve goes down into the block, what happens is that material can flare outward on a straight wall sleeve. And so if the register isn't flush, when that sleeve goes down, over time, as the block flares out, the sleeve can pull itself down. So what we ask our installers to use is a flange top sleeve in that particular block. Flange top sleeve being this ring right here. Those of you who are familiar, you know what I'm talking about. Those of you who are not, flange top sleeve is you cut a counterbore on the deck of the block, similar to that LS7 that I mentioned earlier. That eliminates the possibility of a straight wall sleeve moving down past its register and dropping down, and thus the head gasket not sealing. And so when the installer has any particular given application, it's so important to know how the sleeve is going in the block. Will it stay flush in the block when it goes in? And is it the proper material for the given application? As I mentioned earlier, you could use gray iron sleeves for most cast iron blocks. As a matter of fact, A lot of installers use gray iron sleeves for the light duty Duramax, the Ford 6.0, 6.4, 6.7, the new 7.3 liter, the Godzilla engine from Ford. They use gray iron sleeves, which is a little softer than the block. But the cast iron is such a nice jacket for the sleeve to go into. In most situations, you're going to be okay. But know that if you use a premium material, it'll be as hard as the block or harder. And so the materials that you use in the block are important, and the way that the sleeve is installed in the block is important. And so that being said, there are different ways of putting in sleeves. I'd like to show you, now getting into the aluminum blocks, I'd like to show you a couple of different blocks that we brought as a presentation today for you to look at. Put a little smaller scale so I can get in the picture. This would be considered half of a V8, as you can see here. This particular block is actually a Suzuki Hayabusa engine. The sleeve, as you see here, closes the deck off. The way that we install it, we cut holes into the top of the sleeve, allows the water jacket, the water to flow through this engine block. So this is an aluminum block. But the sleeve that goes into the block goes into a hole like this. Look at that. Now, as you look in this block, you could see that the water jacket is exposed with the sleeve that we put into it. Why I'm focusing on this particular this type of installation is the seating area for the sleeve is here, down below. The counterbore on the deck is right on top. So the sleeve, when it goes into that block, it has to seal that water. This is a wet style sleeve. We call it an amphibious sleeve, meaning the sleeve is pressed dry down below, but yet the water flows around the sleeve to cool it up in the top of the block. This type of application is quite common for sport compacts. So you'll see this in a B18 Honda. You're going to see this in a K24 Honda and F20C S2000. You'll see it in Mitsubishis. You're going to see it in Subarus as well. In the V8 world, we do a wet sleeve for the LS engine. A little bit more tricky on the V8s. And the reason is there's not a lot of room to put a wet liner in the V8 and have it stay stable because there's so little material left in the block. The one thing I wanted to impress upon you is when a sleeve goes in a block like this, we use no sealer of any kind to put that sleeve in the block. Sealer or Loctite sleeve retainer is actually a band-aid in our mind to keep the water from leaking. But if the sleeve is installed properly into a block like this, be it a V6 or a V8 or an inline, if the sleeve is installed properly, no need for sealer. The press fitment itself should hold the water in every application. Many installers do get nervous though, which we can't blame them, obviously. And they'll use different forms of sealer when putting in those sleeves. Nevertheless, sealer in that situation, in our mind, is a band-aid. It's not a necessity. So, moving forward, there are different blocks that I wanted to focus on and different installation applications. So, for instance, one of the most commonly sleeved V8 blocks in the market today, the LS3, the LS7, the 5.3 liter LS, the 5 liter Coyote V8. These blocks are sleeved very commonly because they're so prominent in the marketplace. There's so many cars out there that use those blocks. The blocks are readily available, although the LS blocks have been swallowed up quite a bit, as you guys probably are aware. And in those particular blocks, there's not a lot of room to get the sleeves into the block. And there's also different ways of putting the sleeves in the block as well. The materials that we use for those blocks, when the blocks are being inducted, force inducted, supercharged, or sprayed with nitrous, it must be the ductile iron that I mentioned earlier. The ductile iron sleeve allows you to put extreme boost levels into the block without hurting the sleeve itself. Transmission may go. you may lose the valves, but those sleeves aren't going to crack at all. As far as the installation, I would like to bring another block into the picture, a Mitsubishi 4B11. There's different ways of installing sleeves, and one thing I wanted to indicate to you is here's a 4B11. This is a Mitsubishi. Mitsubishi makes an excellent sleeve. I mean, an excellent block, but under extreme boost levels, they crack quite easily. We recommend when putting in the sleeves, the most common way is heating the block and dropping the sleeves in at room temperature. No need to freeze the sleeves. On the other hand, a nice way to put the sleeve in is using liquid nitrogen, which we could talk about later if you guys have any questions. When you heat the block or use liquid nitrogen, the nice thing about it is the sleeves, which this will make you nervous, these flat sides on the sleeves, because the bore spacing is so thin, or so narrow, I should say. But the sleeves go in just like that. They drop right down into place. Thank you, Daniel. And so, you know, it's daunting when you get a V8 or a V6 that uses flats, as you can see here, these flats that are in the block. It can be a little daunting for the average installer. It shouldn't be though. As long as you've got heat to the block, or you freeze the sleeves, even though they have the flats on them, the sleeves do go in quite easily. You have to clock them just a bit as they go down the block, but it shouldn't be enough to concern you. Moving on, another block I wanted to focus on, or some other blocks I want you guys to focus on, which is unusual for the V8 market, are Audis. The Audi blocks, in our estimation, perhaps the finest block made in the world. What we mean by that is the aluminum is so tight. It's a hyper-eutectic aluminum. It's so tight. It's so dense. It's really difficult to machine. What they were intended for, they're perfect as far as we're concerned. Either the V6 Audi, the V8 Audi, or the inline four-cylinder. The RS3 block, which is a block that's commonly sleeved in the marketplace. Now, the downside to sleeving these blocks that aren't the domestic V8s is it's a smaller bore. So you have to require getting some new tooling. But I want you guys to be aware of something. The Audi, 5-cylinder Audi, the 6-cylinder Audi, the 8-cylinder Audi, or even a 10-cylinder Audi block, which is also used in the Lamborghini, those blocks are anywhere from $12,000 to $16,000. And when sleeving those blocks, they're tedious. But there is a lot of ways to make money sleeving those blocks. So I would ask you guys to consider doing them. But the hyper-eutectic blocks, being again the Audi or Mercedes, which are coated, which Rob mentioned earlier, the BMW, which has some coating or AliSil, or the Porsche blocks. These blocks are highly profitable if you do it right. On the aluminum blocks that are hyper-eutectic, one other thing I'd like you guys to note, I'd like you guys to jot this down. I've mentioned sleeve hardnesses and quality. That's number one. Sleeve drop and how the sleeves are installed, that's number two. This will make you a successful shop. The other thing that's highly important is when sleeving hyper-eutectic blocks, should they walk into your door, is the installation is not like a V8, Chevy, Ford. The hyper-eutectic blocks are very brittle. As good as that aluminum is, they despise being shocked. What I mean by that is a hyper-eutectic block that is heated up in an oven. Typically, we would heat up an Audi block or a Mercedes block or a BMW. We heat a block up to about 325 degrees. The sleeves are installed at roughly 1,000th interference fit. With that interference and that block being heated, the sleeves will drop right into place. But we had to learn something the hard way. When we first started sleeving Audis, roughly 15 years ago, we sleeved some Audis in here. We were making sleeves, but we had the opportunity to install sleeves as well. We heated the blocks and we froze the sleeves thinking we needed some extra time to get the sleeve in the block. This is one thing I want you to remember. You can never heat a hyper-eutectic block and freeze a sleeve and drop the sleeve in the block and think it's not going to crack. We learned the hard way. We ruined a number of blocks. As the blocks were cooling in the shop, it was towards the end of the day, you could hear each block crack as the machines were down. Bink, bink, bink. It was heartbreaking. It was something we had to learn, but this is something you don't need to learn the hard way. You could learn from somebody else's experience. We have a good customer, Adrian Gosney at Gosney's Engineering in the United Kingdom. Adrian happened to be on the phone with me one day, and we talked about this particular problem. He had mentioned he'd learned this himself the hard way. He had sent something to me immediately in the mail on how to sleeve hyper-eutectic blocks. It was a service manual that's produced and disseminated in Europe. I've never really seen one in the United States, but this was the manual. This particular manual is a manual on how to sleeve hyper-eutectic aluminum blocks or how to service them. You could find one on the internet. I highly recommend getting one. It's produced and published by Motor Service International, Kolbenschmidt. And the reason for this is the Germans and the Austrians, they needed to make sure that their blocks were being serviced properly. And so if you get an opportunity, look for that and buy it if you're going to get into those blocks. These blocks are coated or they're either a coated Nicosil, or an alusil, which is an impregnated surface to the inner bore on those blocks. And they require specific honing applications if you're going to hone the block without a sleeve in it. Well, these blocks are great up to about 390 horsepower, or as much as 600 horsepower if you're going to push one of those hyper-eutectic blocks. They're not much better than that, though. Again, they were great for what they were intended for, but as we know, we always push the limit when it comes to engine building. And so these blocks do need to be sleeved. And so when you're getting into a hyper-eutectic block, as I said, an Audi, a BMW, a Mercedes, put the sleeves in at room temperature if you're going to heat the block, or leave the block at room temperature and freeze the sleeves when you drop them in, and you'll never have a problem. Getting back to the aluminum blocks and the sleeve drop, now that is something that the kids, let's say, are really aware of in the aftermarket. They get on the internet and they see the most common issues for sleeving blocks, which is sleeve drop. The older folks in the industry probably don't pay attention to that, although it's something that they're obviously aware of. And so it's something that we fight in regard to marketing. It's something that we fight with the younger crowd who are trying to build a high performance engine, be it a V6 or a V8 or even an inline 4. And so sleeve drop is our greatest enemy, frankly, when it comes to sleeving those blocks. And so what's something that we do recommend, and we can talk about this later if you have any questions, but something that we do recommend is when the sleeves are installed into those blocks, to come back in with the secondary application of pressing the sleeve down into the block a second time. Subaru, I'm gonna show you a block that is high, this is a Subaru EJ25. This is a Japanese engine, very high quality aluminum. But these particular engines have a reputation for sleeve drop. And so the sleeves, they go in just like I indicated with earlier, and they drop right down into place. And these are cooled on the deck of the sleeve by the water jacket, pre-drilled. They go in. We've had certain occasions, thank you, Daniel. We had certain occasions over the years in some of these Subarus where the sleeves have been installed in the block, pressed down a second time to ensure that they've met their counterbore seating surface. The blocks have been put together, they run, and the sleeves drop. It's infuriating, it's frustrating, but the engine builder brings the block back, asks us what we can do about it. We've surfaced the deck of the block, press the sleeve down again. As far as we're concerned, it's down in its seating area, and the sleeve will drop again. There's nothing you can do about soft aluminum. And in all the engines that we ever produce sleeves for, as far as in the racing industry, the only one that we've ever really seen this as a common problem, which is not common at all, would be the Subaru. A soft block is a soft block. There's no way around it. It's not your fault. It's not the engine builder's fault. It's not the racer's fault. Sometimes it happens. But what we do recommend, getting back to that, is what we do recommend is putting the sleeve in the block, pressing it down a second time. We even recommend, again, it could be a V8, a V6, or an inline 4. If you have the time and the patience to do this, take the block, put it in an oven, heat it up. Doesn't need to be more than about 180 degrees. Put a plate over the top of the block if you have it available, and press those sleeves down a second time to ensure that they've met their seating area, as I've indicated earlier, met their seating area. And you'll never have a problem going forward from there. Some of these engines have spray-in liners. Ford Coyote, you've seen that, I'm sure. Some of you guys have seen that on the 4.6 liter Ford. You guys may have seen it in the LS3 Chevy block. An LS3 has a cast-in liner. Cast-in liners from General Motors, they have either a spiral lock or this vertical lock, as you see here. And in those blocks, when an installer is machining it out, occasionally, not all of the iron will be machined out of those blocks. You won't see it in a Ford. You won't see it in that Subaru that I showed you earlier. But in the Chevys, you do see it occasionally. Don't let that bother you. There are some installers that realize when they've machined the block to install the sleeve that not all the iron is out of there. What we've done over the years, working with some scientific labs actually, we found that if the cast-in iron is below the stroke or at the bottom of the stroke, you could put the sleeve in. In this situation, we do recommend using a Loctite sealer on the other hand and press the sleeve in and go. Anyway, so on some of those blocks, you'll have to machine that away. And in putting the sleeves in, don't let it bother you. So there's the installation of that particular sleeve should always be a flange sleeve. And the reason is you can't register a straight sleeve in an aluminum block which hasn't cut all the iron away. Becomes a liability. So a flange sleeve is necessary. So there are spray-in liners. You'll see this in the Audi V6, the 3-liter Audi V6, which was released in the end of 2018 as a spray and liner. It's hard. It's a real hard material, but it is iron ultimately. You'll see that in the Subaru. You see this in the General Motors blocks, LS3 specifically, LS1, LS2, same thing. You got to cut that iron out of there, and you'll see different patterns on how the sleeves are installed. Should you get into a foreign block like a Ferrari, you might even see something to this effect, this type of spiral lock. This particular sleeve, which is out of a 1958 Lampretta engine, they have a spiral lock where they lock it into the head and then drop the sleeves down into a seating area, secure it in the block. It's incredible technology. Was it right or wrong? I don't know, but you may see something like that. Spiral lock, removable liners. As I indicated, the LS7 has a removable liner. These type of applications, although there are different manufacturing processes, a sleeve, on the other hand, goes in basically only one way. A straight wall application, as I indicated earlier, or a flange stop application, as you see here. The nice thing about the flange sleeve is it can go in with almost no press fit. Oftentimes, I think you'll get customers that are rolling the door that are on a budget. They want to fix an LS block, but they only want to sleeve one hole. It's unusual on an LS block because if you sleeve one hole, if you sleeve the one hole, as you guys are probably well aware, it pushes material into the neighboring hole. So flip it on its side here, this way, show the back of the block. Yeah. So as you see here, you put in one flange sleeve, the material would be pushed into the neighboring bore. And although you're trying to save some money or the customer's trying to save some money on his budget, not the best of jobs to do it that way. Thank you. On the other hand, budget is budget. And so what we do recommend, if someone is only trying to sleeve one hole, put the flange sleeve in, 0.5 to 1,000 press max, and you may be able to get away with just doing the one hole. The best thing to do is to do the entire bank, all 4 holes. And if the customer wants to stay at standard bore, he can stay at standard bore. That being said, that's kind of, that's really all I wanted to focus on in the aluminum blocks. I don't know if Rob, if you have any questions for me, but sleeving, one last statement before I take any questions. Sleeving, as I indicated with that Coke can earlier, it's really not rocket science, as you guys are aware. The science is figured out for us by the factories. They're so smart. I've learned so much from the research departments at both Ford and General Motors. It's incredible. And I realize how little I know, but they figured out so much for us. But again, their blocks weren't intended to do what's being done now, is to make a block bigger in the bore, stronger, faster. They weren't intended for that. So the science has been already figured out for us. What we're trying to do is to reinvent the wheel, if you will, to make it last for an application that it wasn't intended for. So it's not rocket science. It just has to go in right. You have to use the right materials. You have to be confident on your processes. You do that, you'll never have any issues. Rob, you have any questions for me?
I do, Dave. Yeah, no, excellent presentation. Hats off to your helper there for some real world applications, because that just it's sometimes hard to put that kind of stuff in a PowerPoint, or this is stuff that in the shop, this is stuff that it's nice to be able to touch and feel and actually see. So we do appreciate it for sure. First question for you, Dave. This gentleman has asked, we have a Jaguar AJ33 block that was originally Alusil, but Jag began installing iron sleeves from the factory in the year 2000 with an aluminum step at the bottom, and they don't look to be flanged. The customer wants to re-sleeve the block to standard bore. What sleeve do you suggest, flange or straight wall?
I do recommend a flange top sleeve for that, because the sleeving surface, or the register at the bottom of the block, won't allow for the sleeve to sit properly in our estimation. As I mentioned earlier, the register down below does not seat properly on that block. So the flange sleeve is something that we've already used for that block. We make a sleeve for that block, and that is our recommendation. You'll be much happier in the end, even though you have to cut the counterbore on the deck of the block, which some installers would rather not do, but it is the way to go.
Okay, all right. Next question. Are there any merits of using chrome sleeves in gasoline-boosted applications? Example, the sleeves that were used in some Isuzu diesels, for example.
Well, we've made steel sleeves that were chrome plated. Some of you guys may know this already. Those are actually used in NASCAR blocks. But the chrome bore is harsh on rings, piston rings, if they're not made specifically for that application. We haven't seen those piston rings. We haven't seen them live. Frankly, the life of the ring is roughly 50% diminished. So although the bore surface is harder with the chrome finish, it really isn't. We haven't found it to be an advantage to do that, other than a drag race application, which, obviously this is a different application. But my answer, if someone was asking for my recommendation, it would be no, don't do that.
Okay, all right. Next question for you, Dave, is a little bit in regards to some machining techniques. And again, if any of these are going to require a little more time or something, I know Dave will get back to you. But Dave, the question goes like this. It goes, recommendations on RPM, feed, and cut depth when boring ductile iron. Also, recommended insert material to deck an aluminum block that's already sleeved without leaving those really weird lines that you always get after the cutter passes the sleeves.
Yeah, I always hesitate to answer this question because we don't sell machinery. And I've got myself in trouble making recommendations, but those are valid questions. I'd be happy to answer that on an email if somebody wants to send me an email. It is daunting, and I will tell you this. You take a cutting machine, you take a cutter, you run it across the deck of a block that's aluminum, and then you go into the iron, it starts to bounce off the iron. And so feed rates are something that have to be learned. I found that suggestions have not been smart on my end, and so it has to be something that's learned. But the carbide tipped cutters are really the only thing that are going to be able to survive cutting across ductile iron, both the bore and the surface of the deck. This is sort of a old world way of going about it, but I will mention this. In some of these blocks that are cut from the aluminum to the iron, as I'm indicating here, you can't help but get some bounce on the cutter as it goes across the sleeve in the aluminum. And this is a suggestion that works, but it's not a great idea, is to belt sand the deck when you're done. Now, guys on the Subarus do that all the time because it's easy. On a V8, it's a little bit more challenging to do it on a V8, but frankly, it gets the job done. And so if you're having trouble with the cutter bouncing on the deck of a block, you can sand it and get it smooth. And this way you can run an MLS gasket safely.
All right. Next question, Dave, is Do you offer any kind of shop training for those that are installing your sleeves at all?
We don't. One thing I probably didn't mention earlier, we are a sleeve manufacturer. We are not a machine shop that focuses on installing sleeves. Although we can, because we have the machinery and that's how we design our sleeves, we do not offer training. That's not what we do. Unless someone wants to learn how to run a two-stroke, how to install a two-stroke sleeve. Rob, I mean, you look at I mentioned two-strokes earlier. Two-strokes were again, we focus heavy on the two-strokes because it's such a large part of our business, not the biggest part of our business, but it's what we've pioneered over the years. To put in a two-stroke sleeve with those ports, that's not easy to do. We trained somebody to do that if they really wanted us to, but on the automotive engines, we don't do that. Again, because we're a manufacturer of cylinder sleeve liners, not an installation shop.
All right, perfect. Next question for you is, what temperature would you recommend as a maximum temperature when heating up an aluminum block before installing a room temperature sleeve?
325 degrees is almost always adequate. We would not recommend going any hotter than 325. I will tell you, on a single cylinder or an inline four, it's not out of the question to go as high as 400. Actually, on a single cylinder like this, it's exactly what we do. We go 400 or 420 degrees. We do not recommend that on an inline block, four-cylinder in most applications, the V6 or the V8. And not only that, it's not necessary.
Okay. All right, and then we had a couple questions that came in actually before the webinar that some folks wanted to ask. And the one they're asking, why do flange type sleeves drop after decking the block? It sounds like maybe they're having some issues with the sleeve dropping after they go to deck it.
Yeah, in my long-winded opening presentation, I neglected to mention that. And so sleeve drop is what I talked about, but why do they drop? And so when a sleeve goes into a block, that Mitsubishi, when a sleeve goes down into a block, Rob, the installers, when they put the sleeve down in, they'll heat the block up, as we mentioned earlier, and the sleeves will go down. And you can hear, I believe you can hear that snap. You can hear that?
Yep.
Okay. That snap is because these two materials are running into each other, okay? What happens is two things happen. The sleeve, as it goes down into the block, it bounces up off the bottom of its counterbore. And so as the block is cooling, the sleeve goes in, it could bounce up 1,000th or 2. The other thing that can happen is the old way of installing sleeves, as you guys are probably aware, is you get the sleeve, hold that there for me, get the sleeve, put it down in the block, and then tap it down into place. Tap it down, tap it down, tap it down with the mallet, okay? Those are plenty good ways of putting sleeves in. But one thing that happens is, especially on iron blocks, the aluminum not so much when you're tapping the sleeve down, but on the iron block, the sleeve, as you're tapping it down, can bounce up off its register, 1,000th or 2 or 3. In the aluminum blocks, again, when the sleeves drop down, it can bounce up 1,000th or 2. Or as the block is cooling down on the sleeve, it could push the sleeve up 1,000th or 2. It could actually push it up 1,000th or 2. That's all that would be required for the sleeve to drop after it's in running condition. Thank you, Daniel. And so that's something I mentioned earlier, is it's so important to know that that sleeve may have bounced up off its counterbore, off its register. The straight wall sleeve, if you can, if you have it in your shop, a press is obviously the easiest way. Just put a plate over the top of the sleeve and just push it down. You don't slam it down. You push it down slowly, and that means it's registered at the bottom. The same goes for the aluminum blocks. If you can push it down, some guys will actually do this. They'll put a torque plate on the deck of the block after they put the sleeves in. They'll set a torque plate on the deck of the block. They'll heat the block up in an oven, 180 degrees or so, and they torque the torque plate back down on the block as it's cooling to ensure that the sleeves are all the way down in that counterboard. So if that's not done, and the installer doesn't know it, and the sleeve happens to push itself up a thousandth or two, which is all that's all that would be necessary for the head gasket to leak, it could become a problem. And so that's what we recommend. Just force it all the way down. A band-aid to that is to leave the sleeves proud in the deck of the block. So some guys will actually put the sleeves in, and they'll have the sleeve, sit above the deck of the block, a couple of thousandths, 2 or 3 thousandths, knowing that the possibility of the sleeve dropping is there, and that'll ensure that it'll never go below the deck. Although that works, it's really hard on the gasket to start, and it shouldn't be necessary as long as the sleeve's all the way down in this register. But that's an operation that can also be performed, leaving the sleeve proud above the deck a thousandth or two.
Okay, all right. And this kind of question kind of ties into that, Dave. They're asking, are you familiar with a process where a block should be vibrated or stress relieved after installing sleeves? And if so, do you vibrate after boring or but before honing? So they're kind of just wanting you to touch base if you've actually used that method before.
We've not used it in-house, but I am familiar with it. Absolutely, nothing wrong with doing that. Yes, but we'd recommend doing the vibration prior to the boring is what we've felt. At least the customers that we work with have found better success prior to the boring.
Okay, all right. And then just touching base again when doing some work on these coated blocks. Will you need different piston rings when you put sleeves in an engine that had a coated bore like Alusil or Nikasil?
The easy answer is yes. The Alusil and Nikasil plated engines like the Audi, as I mentioned earlier, the BMW, the Porsche, the H22 Honda block, which is a coated surface. They run just a straight cast iron ring, and you want to run opposite materials against each other. And so, yes, when sleeving a block that's coated, it's recommended to run an aftermarket ring. We'd recommend running an aftermarket ring. The rings these days the aftermarket rings usually are the nitrided surface ring, which can run on either surface. But that is what we recommend, yes, or a chrome faced ring with the cast iron bore. So the answer is yes. I will leave a caveat in there. We know hundreds of installers who have put in OEM pistons back into a sleeved block, be it an Audi or BMW or the Porsche. And the reason is the aftermarket pistons aren't always available or have never been made. And the blocks and the engines run just fine, but the end user needs to know that the ring life should be diminished by upwards of 30% right off the bat. So it's not as though a failure would happen. At least we've not seen any failures happen. But it's just hard on the ring. It's going to wear down quick.
Okay, all right. Well, one last question for you here, Dave, and then I know we want to respect everybody's time today in regards to getting back to work and that kind of stuff. And so, Dave, the question is, do I need different piston clearances when running sleeves in some of these aluminum blocks that had a coated bore? Like after I put the sleeve in, is it important to have a different clearance?
Yeah, I'm so glad someone asked that question. Yes, the cast iron or the ductile iron does not expand nearly as much as aluminum, as I think most people understand that. And so we recommend upwards of a half thou to 0.8 of a thousandth more piston wall clearance on a sleeve engine. So the answer would be yes.
Okay, perfect. Well, if we get any more questions in, like I say, we'll get those over to Dave to get those answered. Really appreciate your webinar today, Dave. This has been, like I say, we get a lot of these questions on the tech line, and especially with some of this newer stuff, and you've really helped bring that awareness to everybody. Hats off to Daniel for helping you there. He won't have to go to the gym today after helping you there. He's got his workout now, so he's
Yes,
all
indeed.
good. But again, we really appreciate your time. Thank you again. And if anybody wants to get a hold of Dave, here's his information. I've got it up on screen here. So this is their tech support hotline right there. And Monday to Friday, 8 a.m. to 5 p.m. You can also email Dave. Right there is his email address. And again, he's always excellent about getting back to everybody, and we appreciate that. So again, Dave, you have a good rest of your day. Thank you very much for the presentation. Really appreciate it.
Thank you so much for the opportunity.
You bet. So what I'll do now, I'm going to go back to Amanda, and we'll wind things up here for you.
All right, real quick, everybody, I just wanted to make you aware about our YouTube channel. So if you haven't already, make sure you go out to YouTube, search AERA Engine Builders, and hit that subscribe button. All our technical webinars end up out there, typically a few days after the webinar takes place. We have our Engine Professional podcast is available in video form out there. There's some great teasers out there for an upcoming Viewpoint with Dennis Quaid. So watch for more content there and more information coming on when that will be live. We got business webinars, we have post tutorials, you name it. There's just so much great content out there. I want to invite you to go out and check it out. And like I said, make sure you hit that subscribe button and turn on your notifications so you know when we post new content. Also, real quick, when you're out and about at your racetracks this summer, watch for our banner. We have a partnership with Contingency Connection. They offer a racer rewards books that goes out to some grassroots racers with tons of great coupons for different companies within it. And then you can see there we got a list of some of the tracks that the banners are at. So we just invite you this summer when you're out and about watching the races to take a look for that banner promoting our AERA members. If you want more information on Contingency Connection or her programs, you can visit www.contingencyconnection.com. So with that, I just want to thank everybody. We know you guys are busy. We appreciate you taking time out of your day to attend this. When you leave today, there will be a survey that pops up. Take a moment, fill that out, let us know how we did. If you have any additional questions for Dave, there's a spot there to enter those. There's also a spot to send information to us at AERA, whether that's future content you'd like to see, any questions you may have for us, and so on. If you need to reach anyone at the AERA team, you can see our phone number is listed there. 815-526-7600 will get you to the main line, and anyone on the team would be happy to help you. Or you can shoot an email to either Rob or myself. Our email addresses are listed there as well. So with that, thanks again, everybody. We appreciate it, and we hope you have a great rest of your day.